Okay, good afternoon, everybody. My name is Ezra Mizrahi. I come from MRV. I will talk today about LTE and how to solve the challenges associated with this. It's actually not new. We'll see later that it's getting more and more momentum. And the name of the game for LTE is not the technology, it's what it enables, actually. And at the end of the day, what we are looking for is to have a much better quality of experience for the end user. Because remember, we are talking more and more providing bandwidth, but this should come along with better quality of experience. So quickly, a few words about MRV. MRV is a global solution provider of packet and optical solution. We have been in this market for the last 25 years. What we are selling and developing is business Ethernet, mobile backhaul, data center, and cloud interconnect solution. And our solutions are sold to major tier one operators worldwide, as well as enterprises, government entities, and later we'll see some of very nice, interesting case studies. Along with our offerings, we have two major product lines, the optical transport and also the packet solution. And next to this exit, I would like to invite you to see our solution and hear from us about real-life deployment scenarios. So I have like 20 minutes, so I might run very fast through some of the slides, so please bear with me. So first of all, a snapshot from GSA. GSA provides a snapshot, and I would say on a quarterly basis, on the level of the penetration of LTE deployment. And in the last year, we got additional 119 mobile operators deploying LTE. And this is worldwide, both in North America and Europe and also in Asia Pacific. And again, the name of the game is to provide more capacity, and also with the new technologies of LTE, the spectral efficiency along with the capacity should provide better quality of experience. And this should address some of the major development that we see in the mobile backhaul domain. Mainly, more and more people are consuming content, and I'm specifically referring to video acceleration, gaming, location-based services, and other services that we'll discuss later. And the operators, the challenge that they need to solve is to keep the average revenue per user. This is the ARPU. And later we see what are the challenges that they need to address while deploying LTE-based services. So in terms of the time axis, moving from 2G, that was mainly based on TDM infrastructure, later to 3G, ATM, along with Ethernet to some of the base station, and LTE is carrier Ethernet, native Ethernet, but this is an IP infrastructure. Not only this, it's a flat architecture as opposed to 3G and 2G, where you have the base station communicating with the network controller in the middle, and each time you need to have a point-to-point session between the network controller and the base station. And also you can see here two major parameters. One is the speed, the bandwidth, both for LTE and LTE Advanced, the uplink, downlink speeds, and also for latency. Why latency is getting very lower for LTE? Mainly because of the delay that is required for the connectivity between base station to base station. This is another innovation and development when we are talking about LTE. For the 3G, the communication was always between the base station and the radio controller. And here we are enabling the communication between base station via the X2 interface, something that I will discuss briefly. So I outlined here like three major ways to access the LTE infrastructure. One will be via a Wi-Fi network. Second one will be via the LTE directly through the cellular network. The Wi-Fi network also provides kind of a data offload mechanism. We see more and more installation with Wi-Fi offload, which improve the network efficiency for the mobile operators. Last but not least, broadband network cloud run. Other terminology for this technique, I would say, would be, instead of backhauling, this would be like providing the mechanism of doing distribution of the communication between the base station radio head unit and the baseband unit. And one of the protocols to accomplish that is CPRI. CPRI is Common Public Radio Interface. We'll see this more and more developing. And this provides better and efficient way to go from the base station via a very optimized infrastructure to the LTE infrastructure. So this is what we call front hauling. So what are the major attributes or the highlights of LTE? So first of all, we are talking about an all IP architecture. Remember, all the elements in the networks are coming with native internet interfaces. And this goes together hand in hand with the deployment. More and more operators are deploying fiber to the base station. So if we have fiber together with Ethernet, we have a win-win situation here. So we are talking about distributed intelligent and also SON, self-optimized network, to deal with the capacity and handover between base stations. And this is an all IP networks, meaning that you need to deal with all the IP protocols and carry Ethernet, that is the transport technology of choice for LTE. We've discussed very low latency, mainly for the handover between the base station and also for location-based services, the data capacity, and remember, the two unique, I would say, attributes that LTE brings for us in order to improve the quality of experience is data capacity, enormous data capacity, and better spectral efficiency. But keep in mind that with these two innovations, still it's very hard to keep up the growth of the bandwidth consumption by the end user. We are very, very greedy human beings. We would like to have more and more bandwidth, and there are applications that help us to accomplish that. And more we are seeing small cells. Small cells started first to be deployed for 3G, and later we moved forward with 4G in order to provide better coverage and better capacity for remote installations. So what are the communications between the base station and the core, the evolved packet core, the EPC? We have two major entities there, the mobile management entity, and this is where we are going to have the control information. The MME function is a control node. So it controls the information and provides a signaling between the end station, the base station, via S1 interface. And then we have the X2, which is used as the protocol to communicate between base station. And we see more and more of the volume of the traffic is going via X2. It is true that the majority is going from the base station to the SGW. SGW, this is another type of S1 interface. This would be S1U. S1U for user traffic, and S1C, this is the interface between the base station to the MME, and C stands for control. So there are few access technology for the RAN. RAN stands for Radio Access Networks. These are straightforward, and I will go through each one of them. Fiber, PON, microwave cable DOCSIS, version 3, DSL, and Wi-Fi. So again, the interface between the base station to the MME for the control information is S1C. For the signaling, S1U is from the base station to the serving gateway. This would be SGW. And also X2U and X2C, U for user traffic, C for control between the base station, mainly for handover. When you move from one base station to another one, and you need to keep this base station synchronized at all times, and in order to do that, to accomplish this in very low latency. So what are the key, I would say, network requirements and challenges when we are deploying mobile LTE solution? I think pretty much these are straightforward, and this is a list. because we are talking about an high-capacity scalable transport, we need to have the bandwidth and capacity in place. Not only that, we need to have the granularity to enable these very special services. Quality of service. Quality of service is being defined in the LTE by a new parameter called QCI, Quality of Service Class Identifier, which actually provides a set of attributes for performance. And specifically, we're talking about GBR, guaranteed bandwidth rate. This is something that high as a mobile operators guarantee for this kind of application. This would be for time-sensitive application. Then you have also non-GBR. This would be like something that I cannot commit. And mainly this would be for, I would say, for best effort. One example is file sampler, FTP. And there is another parameter, the maximum bit rate. And altogether, when you put this together, you have a set of QCI of attributes that mainly measure the performance. So you have one QCI per each flow, per each bearer. Next is service OEM, something that got very nice improvements along with the latest MEF carry Ethernet SOM, service OEM. And there is a new standard that actually is an extension to an existing standard, MEF 22.1 and now MEF 22.2 that cover this and other aspects, including timing and synchronization. Multicasting, another requirement for gaming and also for software download for if you need to do a bulk software download for multiple base station. IPv6. IPv6 is going to be something that we'll see more and more. Why? Because of the scale. More and more base stations. Each base station, what we call E-Node B, can communicate with 32 neighbor base stations. And the way to achieve this has two aspects. One, topology. We need to have an E-LAN connectivity, multi-point to multi-point, and also scale. The last but not least, as opposed to 3G, where the channel between the user equipment, the smartphone, is encrypted, here, since we are talking about an IP network, we have the vulnerability here that someone can break into the network. So we need to have IPsec tunnel when using untrusted networks, and this has implications. Why? Because of the overhead, and the overhead has some implication on latency. So these are real major challenges that we'll see how to address them. I mentioned MEF 20.1, and now we are talking about MEF 22.2, that in the first year, the whole purpose was to address all the aspects and attributes of mobile backhaul deployment before LTE. And naturally, some of the attributes we are talking about are the UNI interface, service types, link OEM, this is the very basic OEM functionality, and all the other parameters, service OEM, meaning end-to-end, providing end-to-end service OEM, and quality of service performance objective. This is what we call CPO. This goes together with the QCI. Everything is addressed by MEF 22.1 and 22.2. Some of the major attributes that are now being addressed by MEF 22 is also the network-based synchronization and packet-based synchronization, the 1588. 1588 provides support for all flavors of timing synchronization, meaning frequency, time of day, and phase synchronization. The last two flavors are critical, mainly for LTE, for time division duplicating, for applications that require time of day, such as location-based services. Thank you for reminding me. Okay, another approach that was put together by MEF is having multiple class of services. Multiple class of services, meaning that so far we had one class of service. And in a lot of cases, I had to overbuild my network to provide the required amount of bandwidth and bandwidth profile for each one of the service providers. And if we are talking about an wholesale access model whereby the mobile operator leasing the infrastructure from an access provider, and I would like to have on the same access infrastructure multiple mobile operators, I need to provide for each one of them class of service. So this opens for me a windows of opportunity because I can charge per each service provider. And more than that, for each service provider, I can define multiple flows, one per each application. So the multiple class of service support the all cell access model, plus it also provides the means to overcome the overbuild of network capacity. Synchronization requirements, really quick. I'm sure you are familiar with these mechanisms, GPS, legacy, TDM. I have to share with you this information. We are having ongoing discussion with mobile operators and wholesale operators. And one of the things we see that some of them are still maintaining the 2G, I mean the SDH and TDM networks for one major reason, because it provides the timing infrastructure to extract the timing and clocking information. Protocol based, this will be on the network level. This would be 1588 version 2. Synchronous internet on the physical layer. This mainly would be for greenfield installation and combination of both. Sync E, for example, 1588. Why? What's the rationale for using both? If Sync E provides only frequency synchronization, whereby 1580N provides all the flavors. So in some instances, you need to provide also time of day and phase synchronization. You would use both of them. So also we have put together a scheme to provide prioritization for the signaling and synchronization. And there are two mechanisms to achieve that. One is to take a UNI interface and providing multiple EVCs. So one of the EVCs will be assigned synchronization information, and I can do even better than that for each EVC to have multiple class of service. And I can sign class of service plus the PCP bit, which is the 8021P for priority for the synchronization information. This is the most critical information, mainly for the LTE. Protection mechanism. And when I'm talking about protection mechanism, this should be multi-layer protection from layer 1 via loss of signal up to layer 2 and above, and actually layer 3. And I'm saying layer 2 and above both for MPLS and also for layer 3. And there are mechanisms in place, for example, the BFD, VCCV, along with Ethernet OEM. And in some cases, we'll see a combination for layer 1, layer 2, and layer 3. At the end of the day, we would like to provide protection for one major reason: availability and quality of experience. So next two slides, I've put together some nice illustration, I would say, of real-life deployment with femtocell. This is the first way of, I would say, the small cell was femtocell. This was mainly for home users. Now we see more and more small cells on the public domain for better coverage and capacity. Picocells and macrocells. Macrocell was the largest, and then pico and micro for smaller capacity and less coverage, and better coverage, sorry. So I've discussed previously some of the access technologies for connection to the cells. And here is a very nice table with all technology choices, which provides 3 dimensions: bandwidth, some of the advantages, and some of the disadvantages. For example, in Europe, DSL is widely available. In United States, North America, it's cable infrastructure. PLC is power line communications. So you see some of the pros and cons, and this mainly region dependent, but this is the way to get into the mobile backhaul and the LTE infrastructure. Here are some trials, some real numbers from operators both in North America and in Europe. Sprint, for example, 500,000 units. Also Vodafone and also AT&T. So now back to reality, some practical things. As I told you, MRV providing both optical and packet solution. And we have one major product line, the OptiSwitch, that allows you to provide solution both for the LTE solution with strong SLA validation. This would be mainly for a 4LG LTE all IP point to multipoint and multipoint to multipoint solution, and also for an wholesale model, whereby the mobile operator works together with the wholesale access provider. And here you need to have also the connectivity via the broadband wholesale fiber networks. And as an umbrella to all of these solutions, there is the provision. Provision enables you to provision the services, manage them, monitor them. And if you are going to do that along with the OEM, you have all the toolkit to provide all the mechanism to guarantee the SLA between the operator and the end users. Really quick, 2 case studies. The one on the left, this is the first worldwide LTE deployment by major one operator in the Nordic region in Europe. So we worked with this operator to enable E-LAN layer 2 transport services, and this goes along with providing end-to-end OEM for strict SLA measurements and also throughput testing. It started with RFC 2544, which is a built-in test equipment, which saves you money rather than using external test equipment. And now it's moving forward with the new standard, Y.1564. And here we provided packet-based synchronization. The one on the right is from a North American. This is an wholesaler provider. And this is a 3G case study along with some small cell deployment. And you see some commonalities between them. At the end of the day, the idea was to provide OEM mechanism in place to guarantee the SLA contract with the end users. The synchronization here is provided by the legacy network. So really, you see that there is a lot of innovation and development in LTE, a lot of challenges. I showed you some of case studies. And I think when we are looking forward, there will be more challenges, but LTE is getting more and more momentum worldwide. And I think there is a lot of pressure on the equipment vendor to come out with a real solution that address all these challenges. And again, I'd like to invite you to our stand to talk with you about your requirements, about real-life deployment scenarios. Thank you very much, and I conclude my presentation. Any questions? No questions? Come on. Okay, thank you very much.
Everyone is shy here.